Good afternoon, everyone. Today, I will discuss some of the numerical problems of the electricity as we have discussed about the theory of the KCL and KVL. So, today we will see some of the questions. Here, first question is given to us. We have to find, first we note down the question, find the value of I in the given circuit and the value of V1 and V2. This is your given circuit. Here this resistance is given of 2 ohm and here this resistance is given of 4 ohm. This is the battery and it is the positive terminal and it is the negative terminal. The voltage of the battery is 12 volt and resistances are of 2 ohm and 4 ohm. So we have to find here the value of I, V1 and V2, where V1 is the voltage drop across the 2 ohm resistor and V2 is the voltage drop across the 4 ohm resistor. So first step is that step first for solving such type of numericals problem is that assume the direction of current flow in the circuit. This is the first assumption is that we have to first assume the direction of current which is flowing in the given circuit. Suppose this is the direction of the flow of current and we assume I current is flowing through the two resistors. It is a closed loop. According to KVL, the sum of all the individual voltages drop in a closed loop is equal to 0. So first we can write that current is flow from minus to plus terminal, then it can be written as 12 minus to plus, then here also current entering to the 2 ohm resistance with the positive terminal and leaving by negative shown in the figure, and here also entering with the positive terminal and leaving with the negative terminal. So in case of load and source, we have defined that we have to take that sign which is the leaving sign in case of load. So 12 minus 2 is the resistance, 2 ohm is the resistance and I is the current flowing through the 2 ohm resistance. So this can be written as 2i minus of 4i is equal to 0. So we can solve this equation. 12 minus 6i is equal to 0. So 12 is equal to 6i and I is equal to 12 upon 6, that is 2 ampere. This is the current which is flowing in the given circuit. Now we have to find the second part of the given question is that we have to find the value of V1 and V2. So V1 is equal to what? That is I into R1. Suppose this 2 ohm resistance is R1, we have assumed only, and this is of R2 ohm. So V1 is equal to I is our only 2 ampere and R is here 2 ohm. So V1 is the voltage drop across the R1 and it is equal to 4 volt. So 4 volt is the voltage drop across the 2 ohm resistor. Now we will find the voltage drop across the 4 ohm resistor. Now we have to write V2 is equal to IR2 because current which is flowing it is same in the cross circuit which is given to us. So this can be solved as V2 is equal to I is the 2 ampere and R2 is the 4 ampere. So V2 is equal to 8 volt. So this is the voltage drop across the 4 ohm resistor. Now we will see the next problem which is also based on the KVL. Question second. In the given question, we have to find the value of current. Find the value of the current in the given circuit. You are at present seeing the lecture by Anuj Kumar. I am working as a faculty in a college. Now we will see the second given question. This is our problem that note down. Here is a resistance of 2 ohm and here one more resistance of 4 ohm and here is the one resistance of 6 ohm. This is our given circuit. This is 6 volt battery plus minus. So this is the given circuit. We have to find the value of current that is flowing in the given circuit. So step first is same. Assume the direction of the current flowing. Assume the direction of the current which is flowing in the given circuit. Suppose here I1 is the current which is flowing in the given circuit and I2 is also flowing in the given circuit. We have assumed the direction of the flow of current that is same in both the loops. Now we will write the equations by using the KVL. Again, current is passing through the 2 ohm resistance and then 6 ohm resistance in this closed loop. In second case, I2 is flowing through the 4 ohm resistance and then through the 6 ohm resistance. Here, while considering this first loop, the flow of current is more in comparison to I2 when we are considering the first loop only. So this can be written as 10 minus, this is current entering from the positive terminal and leaving from the negative terminal. So this can be written as 10 minus 2 into I1 is the current and this again plus minus then minus 6 I1 is the current which is flowing through the 6 ohm resistance and I2 is flowing on the second loop and the 6 ohm resistance is common in between the first loop and second loop. So we can write, if we are considering first loop, here current is more then I2 is less and it is equal to 0. This is equation for the first loop. Now equation for the second loop, that will be minus 4 here plus minus 4 I2 and plus minus then minus 6 and then here also plus and here is minus then minus 6 of I2 minus I1 is equal to 0. This is the equation in the second loop. For the second loop, this is the equation. Now we have to solve these equations. So considering equation first and we will see that what are the value of I1 and I2. So this I1, this can be solved further for this one, that is it will provide us 8 I1 minus 6 I2 is equal to 10 and here this one second one will give us, that is 6 I1 minus of 10 I2 is equal to 6. So we here multiply equation third by 6 and equation 4 by 8. So this can be solved. This one is got cancelled after multiplication. This will become 48 I1 minus 36 I2 is equal to 60 and this one give 48 I1 minus 80 I2 is equal to 48. So this will got cancelled, and this one here positive and here is minus, then it will provide us 44 I2 is equal to 12. Here I2 it will become 12 upon 44, and this it will be 0.27 ampere. So I2 current which is flowing, we find the value of I2, that is 0.27. It is flowing. Now we will find for the value of I1, that will be, we will put the value of I2 in the equation first, or in we can say third. Okay, this one 8I1 minus 6I2 is equal to, so 8I1 minus 6I2 is equal to 10 from third. Now we put the value of I2, put the value of I2 in the equation. So 8I1 is equal to 6I2 plus 10, and 8I1 is equal to 6 into 0.27 plus 10, and it will become I1 is equal to 11.62 divided by 8, and it will be 1.45 ampere. This is the current which is flowing in the loop first.